We went over the extra credit just a moment ago, and so if you did the extra credit, be sure to send that into my email and I'll check that. For now, though, classwork as we get started today, page 558, I want you to do numbers 1 through 4. Page 558, do numbers 1 through 4. Take just a few minutes to work on these. And of course, if you get probabilities, we always reduce ratios to lowest terms. Audrey, does that trigger your OCD? Oh. She's like, yeah, change that last number to a 3. That'd be so much better. Michael just got it. Brandon's still confused. No. I'm just picking on you, Brandon. couple more minutes to be finishing up. Again, I think it's easier if we use ratios rather than decimals, so we'll continue to do that. As long as you're efficient in canceling with ratios, you don't even have to worry about reducing. Looks like most of us are about finished in here. If you're watching and want to pause the video to give yourself time to finish, that would be fine. Those of us in here, go to put your pencils down even if you're not finished, and we'll take a look at these together. Number one, Sanders placed 12 colored pencils into a box. 2 red, 4 blue, 3 green, 1 purple, and 2 white and red ones. I'm not sure how that works on a colored pencil unless it's talking about the wrapping on the colored pencil. That's a little odd. No yellow. So what's the odds she pulls out 1 with red or 1 with green? Now, it didn't say a red one, but 1 with red. How many of the pencils have red, class? 4. The 2 that are red and the 2 that are white and red. So that's 4 pencils out of 12. And then it says or. Class, what do I do when it says or? Because she's only making one selection. She's only pulling out 1 pencil. And we're just trying to see the odds of either this or that. So we're going to increase our chances by addition. What about 1 with green? Well, the only pencils that have green are the green pencils, class. That's 3 out of 12. Are these mutually exclusive or not? Yeah. If it's got none of the ones with green have any red, and the ones with red do not have any green. So they're mutually exclusive. We just add to get, class, 7 to 12. How many had that for part A? Questions?
I just didn't see 2
You didn't see
and red.
Gotcha, with red. Gotcha. All right, so then it says pulls out 1 with white or 1 with red. Well, how many have white, class? 2, and that's the red and white ones. Both have white on them. How many have red? 4, and that's the red ones and the ones with red and white. Are these mutually exclusive? No, because the red and white have both, and so we have to subtract away the 2 that are both red and white, and we end up, class, with 4 to 12, which reduces to 1 to 3. And there's our answer there. How many have 1 to 3 for letter B? All right, questions on that one? Letter C, she pulls out 1 with green or 1 with purple. Well, how many have green? 3 to 12. How many have purple? 1 to 12. Are there any others? Any overlap there between green and purple? No, so we just add them to get 4 to 12, which is 1 to 3 again. Questions on number 1? And we'll go 3 for 3 on this one. All right? And maybe it's just little details like reading carefully, right? If nothing else, we learned that lesson from this. All right, Tracy is having a tea party. She has 3 white teacups, 1 white napkin, 4 pink teacups, and 5 red plates. If it's my tea party, we have 20 napkins. And anyway, she only has 1 napkin. What are the odds she pulls out a plate or a napkin? Again, aside the fact that there's a difference. Maybe, you know those little games where you like control a little claw, it comes down, you try to pick up a toy? Your dad's really good at those, I understand. Anyway, how many are not good at that? And you try for one thing and get something else? How many are like, no, I'm boss at that. I get exactly what I want every time. Well, anyway, maybe she's trying to pick something out. Maybe it's pick something for your tea party. Anyway, what are the odds she pulls out a plate or a napkin? Well, how many plates, class? 5. Out of how many items listed? 13. And then it says, or she pulls out a napkin. Well, how many napkins? 1 out of, and since it says or, class, we're going to, is there any overlap between a napkin and a plate? No, now some of you might function that way. How many occasions will we use a napkin instead of a plate? Maybe you're eating at home, or we do that with our kids sometimes. I don't feel like getting you a plate. Here, put this on the napkin, and you're a lazy self because the napkin's right there on the table. Plate, I have to get out of my chair and walk. And so, what are the odds of napkin or plate, class? 6 to 13. How many have that on part A? Part B, she pulls out something white or a teacup. Well, how many white things are there, class? 4. The 3 teacups and the napkins, that's 4 to 13 that it's white. What about the odds that it's a teacup? Well, how many teacups are there? 7 to 13, the odds of a teacup. How many are both white and teacup? 3. So there's 3 units of overlap that have to be subtracted. So we're going to end up with 8 to 13. How many recognize they were not mutually exclusive? You subtracted the overlap, got the correct answer. Good, excellent questions on that. Let's see, she pulls out a plate or a teacup. Well, how many plates? 5 out of 13. And how many teacups? 7 out of 13. And is there any overlap here? No. So we'll just add it together to get 12 to 13. 12 to 13. Pretty much anything but the napkin, right? We couldn't even say it's the complement of napkin. 1 minus the 1 to 13 napkin is the 12 to 13 everything else, which was plates and teacups. How many got all 3 answers? Correct. 6 to 13, 8 to 13, 12 to 13. Like 3 for 3. Good questions. All right, take a look now at number 3. And now instead of making a single selection where the options are mutually exclusive or not, we're making 2 or maybe 3 selections. And those selections may or may not affect each other. How do we describe selections that do not affect each other? Independent. If they do affect each other, dependent. A single selection has multiple possibilities. If there's overlap, we'd say they're not mutually exclusive. If there's no overlap, there are. Again, understanding the difference between those descriptors. All right, so Steve has 2 pairs of dress shoes, 3 pairs of casual shoes, a pair of running shoes, and 2 pairs of boots. How many items, how many pieces of footwear, class? 8. I'm seeing 8 here, okay? So the pair of dress shoes and a pair of boots with replacement in that order. So dress shoes, class. 2 out of 8. We can reduce it later. I would suggest keeping it that way. With replacement, so he pulls out a pair of dress shoes. Pop just dress shoes back in. Rummages around, pulls out a pair of boots. What's the odds of boots now, class?
2 to 8.
Also 2 to 8. We had 2 pairs of boots. There were still 8 items though because we put the other ones back. And since it says and, class, we're going to multiply. So it's not 4 to 8, but rather if we reduce twice, 1 to 4, 1 to 4, class, 1 to 16. How many had 1 to 16? Excellent. Look at the next one. Pair of casual shoes, then pair of dress shoes without replacement. Okay, odds of casual shoes, class. 3 to 8. No replacement. So we keep the casual shoes, and then we're also going to rummage around and we get out a pair of dress shoes, class. 2 to 7 now. Both pairs of dress shoes were available, but only 7 pairs total. I can do a little reducing here in class. I'll get 3 to 28 chance. How many had 3 to 28? All right, questions on that? All right, look at the last one. Boots, then casual shoes without replacement. All right, odds of boots. 2 to 8. Then casual shoes. 3 out of 7. We can again reduce them once again, and we end up with a 3 to 28. How many got that again on the last one? All right, questions on
I saw put over 9.
Oh, so you increased the number available instead of decreased. It makes sense though why it's decreased, okay? Any questions? That was a good comment. Okay, she observed what she did, so she knows to avoid in the future. Any other questions, comments?
So does he like tie his shoelaces together and just grab a pair of shoelaces and out comes he
Except the
goes with
boots
it?
though, like what do you do with
Or-
the, I mean, boots don't have shoelace, well, most boots, I mean, I've seen some boots, I guess. Anyway, questions. All right, let's take a look at the last one. Tony has 3 blue ties, 2 red ties, 1 black tie, 2 white ties, okay, and a green tie. How many ties is that, class? 9 ties. Okay, red tie, then white tie with replacement. All right, what's the odds of red tie? 2 to 9. With replacement, white tie. 2 to 9. And since it said and, we will multiply to get 4 to 81. Not 4 to 9. That would be if we added. We're multiplying. It says and 4 to 81. How many had that for letter A? Letter B, blue tie, then green tie without replacement. Well, what's the odds of blue tie? 3 to 9. And then without replacing it, green tie. 1 to 8. We can do a little reducing here. We get 1 to 24. How many had that? Question? All right. White, and don't pull Michael. White and then blue without replacement. Okay, what's the odds of white, class? 2 to 9. No replacement. We're taking a blue tie. 3 to 8. All right, we do a little reducing here, 1 to 3, a little reducing here, 1 to 4. We get 1 to 12. Our answer there, how many had 1 to 12 for letter C? All right, questions on the classwork? Questions? All right, let's do a little bit more practice. Flip back to page 522. Page 522. And do numbers 7 through 10. At the bottom of the page up to the top of the next page. 7 through 10. Nice thing about these, there's only one part in each problem, so it's not 3 in 1, but just a single problem at a time. Several people finished up. Take just a moment or two longer, and then we'll take a look at these. Tell you what, if you already have the answers, take the next moment to turn them all into percents. Go and find percent chances on these if you've already got the ratios. If you're still working, just finish up, but I would like to give percent answers as well, to the nearest 0.1%, so 3 decimal places. But written as a percent, because that's way cooler than just a decimal. All right, let's take a look at these, even if you're not quite finished. Number 7, there are 12 forks, 15 knives, 13 spoons in a drawer. Probability that a fork, then a spoon, then a knife will be chosen at random without replacement in that order. First thing you should have found was the total number of utensils, and it would have been 40 utensils. The first draw is a fork, that's 12 out of 40. Next draw is a spoon, that's 13 out of 39. The next draw is a knife, that's 15 to 38. Notice the numbers dropping because of the non-replacement. Multiplying it out as you do some canceling, I got 3 out of 76 chance. How many had 3 to 76 is the odds? And as a percent class, that would be?
3.95.
Just a 3.9% chance of that occurring. Number 8, Samantha has 20 hair bows specifically. The odds of pink, then another pink, then a blue without replacement. Well, pink is 7 to 20, but another pink is 6 to 19, and then the blue is a 6 out of 18. We reduce it all down, I got 7 to 190. How many had 7 out of 190 chance? And as a percent class? 3.7% chance of that happening. Number 9, teacher had several different colors of construction paper, 42 sheets of red, 25 sheets of yellow, 35 sheets of blue, 18 sheets of green. Blue, then yellow with replacement. First of all, I should have found 120 sheets of construction paper. The odds of blue are 35 to 120. With replacement, the chances of yellow are then 25, still out of 120. Reduce it down to get 35 to 576. 35 out of a 576 chance, which as a percent? 6.1% chance. The number 10 electronics store had 40 computers, 30 tablets, 50 phones. That's how many devices? 120 devices. Tablet, then phone with replacement. So tablet is 30 to 120, and then phone is 50 to 120. Those both easily reduce. You get 5 to 48 chance. And as a percent chance class, 10.4% chance. That's the best odds of the 4 problems that we just worked. Seems like we got them all right. Feel like we're good with this. All right, well, let's go ahead and review over the entire section now. I want you to start by doing this section where it says review of probability and frequency distribution. Do numbers 1 through 8, bottom of page 523. Page 523, and do numbers 1 through 8. Should read directions carefully for each section so that you know what they're asking. perfect squares. What are some of our perfect squares, class? 1, 4, 9, 16, 25, 36, 49. Anything that's a result of squaring an integer. Technically 0 would be a square as well, wouldn't it? Because 0 squared is 0. So 0 squared is 0. 1 squared, 2 squared, 3 squared, 4 squared. These are perfect squares. The numbers you get when you square an integer.
Oh.
Yeah, those are called squares. Anything else is called, anyone remember, it's a term we haven't heard for years. A non-perfect square? A surd, S-U-R-D. A great term for Jeopardy one day. You're gonna remember it and win lots of money. And when you do, remember your math teacher. Or they might say, what term refers to the root of a surd? Irrational.
Confuses me.
Perplexes you and causes you consternation?
Yes. Out of 300 games, she bowled at least 4 strikes in 261 games.
Ah, so how many games did she bowl?
300.
All right, and we're looking for the odds that she does have at least 4 strikes. Well, how many times has she had at least 4 strikes?
261.
Of her how many games?
300.
There we go. Does that make sense now?
Yes.
Because you're looking, you're like, man, there's 3 numbers here. Well, one of the numbers isn't a number you're interested in. It's just kind of describing how successful her game was. I usually have 1 strike each game of bowling, and it's usually like the first or second frame. So everyone thinks I'm really good, and then after that, it's all gutter balls. So I start off really hot, and then I just
put up the sidebars.
Yeah, you know, it looks bad to have bumpers up, but it also looks bad to have gutter balls.
I mean,
So
if you have kids, though.
Ah, you say it's for the kids, it's for the children. Yeah, I'm cheap. I don't take my kids bowling. I leave them home with a babysitter. Actually, that's not cheap either.
Let them come watch.
You sit there and watch Daddy. Now, Wii bowling. I was good at Wii bowling. Because I know in theory, like my head knows how it's supposed to be. In Wii bowling, you can line up the angles and all, which is perfect. I know exactly what ball's supposed to hit. And in Wii bowling, you can make it happen.
Yeah.
And then in real bowling, somehow the way it comes off the fingers, it just doesn't go where I want it there, not the gutter every time. Anyway.
Did it go behind you when bowling?
Yeah, I've seen that before.
Hit a couple people.
Hit a few people bowling just for the fun of it. Only in Wii bowling, not in real bowling, though, right?
Oh.
You do that in real bowling, okay?
Yes.
No.
I do.
Not usually.
Usually.
Not on purpose.
Just another minute or two to finish these up.
Michael looks a little mad.
That's his, I hate taking pictures, but I'm going to try to look cool face.
Yeah. Or my coworker, Mr. Strange, just died.
So on that happy note, page 523. Raymond has a bag of balloons that haven't been blown up yet. There are 50 balloons in the bag, 13 red, 16 blue, 21 yellow. What's the probability Raymond either chooses a red or a blue balloon? Well, how many outcomes would be called, quote, successful outcomes, class?
19 or 29.
29 successful outcomes. Now, if you found the probability, it's 29 to 50, which would be, a 58% chance. But it was just asking how many of these outcomes are considered successful. Number 2, Victoria has to pick a random number between 1 and 50. What's the probability she'll choose a perfect square? Well, Brandon, how many perfect squares are there between 1 and 50?
7.
7 of them. 1, 4, 9, 16, 25, 36, and 49 out of 50. So 7 successful outcomes. If you were finding the probability, that's 7 to 50 or 14%. But it was just asking how many outcomes are successful. How many of those correct for 1 and 2? Brandon's like, now that you showed me what a perfect square is. It's been a while. I mean, that was first quarter, right? So I mean, in his defense. All right, number 3. Is that a valid group of probabilities, class?
Yes.
Yeah. They're all between 0 and 1. They add up to 1. What about number 4?
No.
No, they are between 0 and 1, but they don't add up to 1, so not valid. Number 5, Elise stayed after church up clean 6 times out of the past 50 church services. So, what's the probability she will stay after church the next time? Based on past history. What's the probability of the complement? Well, what's the probability that she stays after church class? 3 to 25, or a 12% chance. So what's the odds? What is the probability of the complement then? 22 to 25, or 88% chance is the complement. That's the odds she does not stay and help after church. The odds are much greater that she doesn't stay. But anyways, if it was volunteer anyway, just out of the goodness of her heart, that's good. Michael's a nurse in the emergency room. Last week he helped 300 of the 2,500 patients that came to the emergency room. So what's the probability if you're a patient, Michael is the nurse that cares for you, class? 3 to 25. What's the probability of the complement? 22 to 25. Same answers as last time, actually. Questions 5 or 6. Number 7, Sydney loves to go bowling. Out of the past 300 games, she bowled at least 4 strikes in 261 of those games. What's the probability that in another random game, she'll bowl at least 4 strikes, class? 87%, or 261 to 300. Actually, that does reduce, doesn't it, to, 87 to 100. Yeah, 87 to 100, or 87%. Number 8, Jesse collects calculators. Sounds like he has a problem. He has 26 calculators. 20 of them are scientific calculators, and the other 6 are worthless. What is the probability that Jesse will choose a scientific calculator out of his collection if it's completely random and he doesn't have a free choice? Class? 10 to 13. 20 out of 26 reduces 10 to 13, or if you found the percent?
76.9.
76.9%. Questions on the 1 through 8.
It sounds like Jesse's problem keeps adding up.
It's a real knee slap right All right. Questions on those. All right, as we round out, I want you to do 9, 11, 13. Let's just do those 3. 9, 11, and 13 on page 524.
And if she's picking a number between 1 and 20, are they trying to count 1
It
and
includes 1 and 20, yeah. So like normally if they're like, hey, pick a number 1 to 20, they're normally including 1 and 20 as possibilities. Yep, good question. We are going to go just a couple minutes past the bell. For sake of time, let's go ahead and take a look at these answers together now. On number 9, certain city, out of the last 365 days in the year, there were 25 days of snow, which means it's not here in Columbus, 131 days of rain, 3 days of hail, and 206 days of clear weather. I'm assuming by saying hail, they're counting that over the fact that it rained, because usually they go together. But if it hails, nobody cares if it rains because it was cool that it hailed. 206 days of clear weather. What is the odds there will be a day of snow or rain? When it says or class, we add. So we add the snow days and the rain days. Take that out of 365. We get, Audrey? 156 to 365 chances. That's 42.7%. A clear day or a rainy day. Brandon?
337 to 365.
Good, 337 to 365. That's a 92.3% chance. What about rain, snow, or hail? Basically the complement of clear days. Abby?
43.6%.
Good, 159 to 365, which is 43.6%. All of those were mutually exclusive. Are we good to go on number 9? Number 11, what's the probability, Tracy has to pick a number between 1 and 20. What's the probability of an even number or a number less than 11? Well, how many even numbers are between 1 and 20, class? 10. Half of them are going to be even, right? How many are less than 11? 10. 1 through 10 are all less than 11. So that's 10 out of 20 plus 10 out of 20, but there's some overlap, right? Some numbers smaller than 11 are even. How many? 5, 2, 4, 6, 8, 10. So we subtract that overlap, we end up getting 15 to 20 or 3 to 4. How many had that for letter A? Questions on that? Letter B, a prime number. What are my prime numbers between 1 and 20, class? 2, 3, 5, 7, 11, 13, 17, 19. So that's 8 prime numbers. How about a number less than 11? Well, we just did that one, class. 10 to 20. But how many primes are less than 11? 2, 3, 5, 7. That's 4. The overlap we have to subtract. And I'm getting 14 to 20 or 7 to 10. 7 to 10, 70%. How many had that for letter B? Okay, good, a few of you. A multiple of 3 or a multiple of 2. What are the multiples of 3, class? Say it with me. 3, 6, 9, 12, 15, 18. The next one will be too big, so that's 6 out of 20. Multiple of 2. Those are even numbers. How many even numbers? 10. So it's 6 to 20 plus 10 to 20, but there are a few numbers that are multiples of 2 and multiples of 3. What are those?
6, 15, 18.
Not 15.
And
6
12,
is 12 and 18. 6, 12, and 18 are both. So we have to subtract that 3 overlap, and we end up with 13 to 20, or 65%. How many had that for letter C? All right, so some testing some number skills there. Yes, ma'am.
I counted 0 as a multiple.
Well, it's between 1 and 20.
Okay.
Yeah, so although we will include the 1 and the 20, we won't include the 0. Yeah, you outsmarted yourself. I've done that a time or two. And then number 13, this is the annoying one, because we're multiplying, which means big numbers. It's just harder when it says and, isn't it? And there are 68 coins in the collection. What are the odds that a penny and then a dime will be chosen with replacement? Well, the nice thing is it's 68 in the denominator both times. 21 pennies, 13 dimes, we multiply. We get a really ugly fraction, Kendall.
2,197 over,
That can't be that big.
1,156 over 2,197.
I'm not sure what you did. Okay, so we've got a penny, which is 21 out of 68, right? And then we've got a dime, which is 13 out of 68. Neither reduced, by the way, and we're multiplying.
I added one extra. Like I had another 13 over 16.
Oh, so you had 2 dimes,
Yeah.
basically. Oh, okay. All right, so we should have had, while she's redoing it here, Michael?
273 over 4,624.
Yeah, 273 to 4,624. On letter B, Kendall, we had a nickel, then a quarter. What'd you get for that answer?
225 over 4,624.
There we go, 225 to 4,624. And then letter C, a nickel, then a dime, then a quarter, in that order with replacement. Who got all the way to the last problem? Abby did. What's your very large answer?
2,925 to 314,432, or 0.1%.
Yeah, 2,925 out of 314,432 chance. That seems really hard to comprehend, which is why I like that she gave it. It was a 0.9% chance of that happening. Very low probability. Homework for this evening is to do page 522. Page 522, a little blast from the past here, numbers 3 through 6. Page 522, numbers 3 through 6. And then on page 532, 1 through 12. Page 532, 1 through 12. We will have our next test in lesson 170. That is on Wednesday. Test coming up Wednesday in lesson 170. So we'll wrap the chapter in our next lesson, be reviewing, in our case on Tuesday, lesson 169, and then lesson 170, our test, over what we've covered in this chapter and the back end of the last chapter. All right, have a wonderful rest of your day, and you are dismissed.